All right, so number one, so Misty determined that she gets 64 miles per 2 gallons of gas from her car as she drives from her house to the ski slope. So part A, create a ratio. So a ratio is basically just a comparison of two numbers of Misty's miles per gallon. So they kind of tell us directly in the wording here, she gets 64 miles per 2 gallons. Okay, so that could be the ratio. 64 over 2. Okay, 64 to 2. Okay, so again, it's just a comparison of the two numbers. Write it as a fraction if you want to. Can we use that ratio now to determine how far Misty can go on 1 gallon of gas? So if we know she goes 64 miles for 2 gallons, the question kind of asks, how many miles would she go for 1 gallon of gas, right? We want to just kind of change the gallons and see how does that affect the, the amount of miles she could go. So really, if you think of this like an equation, 64 over 2 equals x over 1, right? 64 divided by 2 is just 32, and x divided by 1 is just x. So it should seem reasonable that if she can go 64 miles on 2 gallons, that means she would go 32 miles on 1 gallon. Okay, so we're just using that ratio to answer the question. And same thing with part C. Part C, how many miles could Misty travel on a full tank of 12 gallons? So let's set up our ratio. Again, we know 64 miles gets 2 gallons, or takes 2 gallons. And my question is, how many miles? So I'm going to put the x up there if we had 12 gallons. Okay, and let's just solve it like an equation. So this side of the equation, 64 over 2, again, is 32. And we know that equals x divided by 12, right? And just remember, when we're solving equations, we want to do inverse operations. So if we have x being divided by 12, and we want to get x by itself, we would have to do the inverse of division, which is multiplication. I'm going to times both sides by 12. Okay, because on the right side of the equation, multiplying by 12 undoes the dividing by 12 when we just get x. And then we could do 12 times 32, which should get us 384. All right, with number 2, kind of a similar thing. Let's see if we can set this up. So Bryn rides her bike 84 miles in 4 hours. Okay, so we should be able to write a ratio then. It would be 84 miles per 4 hours. Okay. So let's use that ratio that we just found to determine how far Bryn can ride in 7 hours. So sometimes it helps to put these units in here. The miles was the numerator, hours for the denominator. So can we use that ratio? If she were to ride for 7 hours, how far would she go? So I'm going to take that ratio. I know 84 miles goes to 4 hours, and set it equal to, we're trying to figure out how many miles she could go. So the unknown is the numerator. That's where the miles is. In 7 hours. Right, so I'm kind of setting up what's called a proportion. Right? When you set two fractions equal to each other, that's a proportion. So in this case, for this example, we could simplify a little bit, because 84 divided by 4 is a nice whole number. It equals 21. Okay, and there are other ways to solve these, but if you can simplify things, might as well. So I just did 84 divided by 4 equals x divided by 7. And then, like we did in the last problem, how would I get x by itself in this one? There you go. Let's times both sides by 7. Okay, because multiplying by 7 will undo dividing by 7. And the 7 times 21 is 147. Okay, and then let's see if we can set up part C now. So if Bryn rides 57 miles at the rate indicated, how long will she ride? So let's set up our ratio again. I know it's 84 miles per 4 hours. All right, so this time if she rides 57 miles, we need to figure out how many hours. So I'm going to put, again, I'm going to keep the units in the same order. The 57 miles is the numerator, and the hours is the unknown, x. Okay, so this one's a little different. The variable that we need, the x, is in the denominator there. Okay, so let's do one thing first though. Let's simplify since we can. Again, this 84 over 4, we know 84 divided by 4 does equal 21. So our equation becomes 21 equals 57 over x. Okay, now this one's a little bit different again because the x is in the bottom, but still we need to get that x by itself. So the only way we're going to get it out of the denominator is multiply both sides by x. Okay, we're going to have to do 2 steps to finish this. Okay, so we multiply both sides by x first. What that does is cancels out the x in the denominator. And the left side is now 21 times x. And the right side of the equation is just 57. Okay, so again, it's a little different. But it's making it where we can now just do one more step. Right, I have 21 times x equals 57. So to solve that for x, since it's 21 times x, I'm going to divide both sides by 21. Okay, and to undo that. And when we divide the 57 by 21, I'm just throwing it into a calculator here, it's about 2.7. Okay, so it would take about 2.7 hours to do the 57-mile ride. All right, then continuing on. So number 3 and 4, now we're getting more into the slope, y-intercept of the more recent sections here. So if they give you a graph and they ask you for the slope, we just need to remember the slope again is the rate of change. So basically, slope, the formula for slope is always the change in, remember that little triangle, delta, the change in y values over the change in x values. Okay, and when we did it, you could do it from a table where we look at the change in the y values over the change in x, or you can do it from a graph. So if they give you a graph, you need to find 2 nice points on the graph. So I'm going to look at, like, and there's more than one option here, but I noticed there's a nice clean point there. And then here's another nice clean point. When I say clean point, it's like going through whole numbers. Okay? So what ends up happening there is I see the change in the y values. To get from the first point to the second point, it went down 1, 2, 3. So the change in y values is, since it's down, is -3. While the x values went to the right 1, 2 units, so +2 for the change in x. Okay, so that makes the slope just be that fraction. It's down 3 and to the right 2. It's -3 over 2. Okay, that would be the slope. And you can verify that's going to continue. You know, if you do that again, if you went from this point now, if you went down 1, 2, 3 over 2, you would get another point on the graph. Okay, because that slope, again, of a line will always remain the same through the whole line. That's what makes the graph a line.
I have a question.
Okay. So the slope again, let's just write the formulas down. The slope will be the change in the y values over change in x. It's always that way. And then the y-intercept is going to be the starting value. Okay, or what that means for us is that it's the y value when x is 0. Okay, because when x is 0, that's kind of where things start, right? So if we look at the table, let's just see if we can get the slope part first. So the change in y, to get from 1 to 7, it looks like it went up 6. To get from 7 to 13, it went up 6. Okay, and if it's not obvious, if you don't see it in your head, you can always subtract. Like take the 13 minus the 7 and you'll get 6. Okay, or 7 minus 1 and you'll get 6. And then the change in x values from 0 to 3 is an up 3. From 3 to 6 is an up 3, right? So it does appear to be constant because our pattern's staying the same. So that makes for this one, the slope would be, again, we have to do it in the right order. It's the change in y over the change in x. So for this problem, it's going to be a plus 6 over a positive 3. Okay, and if you can reduce it, go ahead and reduce it. What is 6 over 3? 2, right? So the slope for part A is 2. And then the y-intercept for part A, where's this thing starting out? You know, when x is 0, the y value is 1. Okay, so in this case, the y-intercept is 1.
I have a question.
Sure.
My question is, what if the numbers weren't constant? Do you still do the same slope?
Right, so that would be similar to like if the, in the last one, if the line, if we didn't have the same change in y over change in x, then it wouldn't be a line. And you couldn't find a slope because it wouldn't be a constant slope, so it would not be linear. Okay, then on part B, let's kind of do the same thing. So if we look at the change in y, change in x. So for this one, the change in y to get from 10 to 4, okay, remember you could do the 4 minus 10, okay, would get you a change of negative 6 or down 6. And then to get from 4 down to negative 4, okay, to go from positive 4 down to negative 4, you're going down 8, right? Now the change in x's on this table, to go from negative 3 up to 0, that's a change of plus 3. And then to go from 0 to 4, that's a change of plus 4. Okay, so it looks like things are changing on this one. Let's see, though, if we write those, if it's a constant slope or not. Okay, so if I do the first set of points, okay, it was negative 6 over positive 3. Okay, negative 6 over positive 3 is what? Negative 2? And the second set of points, the change was negative 8 over positive 4, right? Negative 8 over positive 4. And negative 8 over positive 4 also equals negative 2, actually. So it appears, even though the numbers weren't exactly the same, they still reduced to be the same thing. Okay, so the slope, this is actually linear, and the slope is negative 2, because they both reduced to that, right? The change in y over change in x was negative 2 for both cases. Okay, and then the y-intercept again. When x is 0, we want to know what the y value is, and we see right there that it is 4. Get a couple more. Number 5, so they give us graphs, and they want us to find the slope and the y-intercept for each. Okay, so if we are given this graph here, okay, let's do what we did before and find the slope, okay, and then we'll find the y-intercept too. Okay, maybe we can find the y-intercept first. So the y-intercept again is right where the graph is when you're on the y-axis. So it's just saying, you know, what is the y value of that point? So I can see just by counting up, it's 1, 2, 3. So the y-intercept is 3. Okay, and I just did that one first because I'm going to use that as one of the points to help me find the slope. Okay, so once we have that point, again, when you do slope, you want to just get another nice whole number point. So I might use like this one here. Okay, and then now all I have to do is count to get from, I usually go left to right. So to get from the green point to the red point, let's see what the rate of change was. What was the change in y values? And then what was the change in x values, right? So the change in the y values, I can see it only went up 1 unit. It went positive 1. And the change for x values, it went to the right, which is positive 2. So the slope of this one would be 1 over 2 or 1/2. Okay, it's going up 1 over 2. Up 1 over 2. That's the slope. Okay, let's look at part B. So part B, y-intercept first, right? So the y-intercept again is where are you on the y-axis? When x is 0, right, it looks like that value is 5. Okay, that's the y-coordinate when you're on the y-axis. And then to get the slope again, you need a second point. So I'll just use the closest one where it's nice and whole numbers. Looks like that point right there. Right, and our slope, we're going to do the change in y over the change in x. So let's do the red point as the first point since that's on the left. All right, we'll just go left to right. So the change in y values, this one actually went down 2 units. And the change in x's is just over 1 unit. Okay, so it's negative 2 over 1, which can be simplified to just be negative 2. Number 6, if a line has a slope of negative 1/2 and contains the point 2, 3, then it must also contain which point? So let's make a little sketch. And I'm just going to make a grid, x and y axis here. I'm going to go 5 on each direction just so I can visualize this. We'll get into using graph paper and stuff later, but just as a quick sketch. So the point 2, 3, okay, again, it's x and then y. So the x axis is the one that goes side to side, and the y goes up and down. So to plot that point, I need to go positive 2 in the x direction and positive 3 in the y. So that point is actually right here. Okay, that's the point 2, 3. And then I can use the slope that they gave me of negative 1 over 2 to get another point. Okay, so I'm gonna treat the negative 1/2. I'm just gonna pretend like the top is the one that's negative, okay? Because it could be either one, right? In a fraction, the numerator could be negative or the denominator, but not both. Okay, because if they were both negative, it would make the whole fraction positive. So what I'm gonna treat it as down 1 unit and then positive 2 in the x direction. So I'm gonna go down 1 unit and over 2, and I'm gonna be right here as my next point. Okay, and this line is going to go through those and do something like this. Right? So I'm going to see what are the coordinates of the point I just drew, the red point. So the first point that they gave us again was 2, 3. If I were going down 1 and to the right 2, the red point ended up at an x value of 4 and a y value of 2. Okay, all right, it was 1, 2, 3, 4 in the x direction and 1, 2 in the y direction. So that would be the point that's on the graph. All right, and then the last one I want to walk through, number 8 here. All right, so again, to be linear, we know we need to have that constant pattern of rate of change where like the slope stays the same, right? So if we kind of look at the pattern to get from 1 to 3, it was adding 2. To get from 3 to 5, we were adding 2. Okay, and the change in x was constant as well with the plus 1. So it looks like the slope is a 2 over 1 kind of thing. So that should make it, it should give us what we need to find the next point, right? If this is linear, that pattern is going to continue. So it's going to be a plus 2 again. So this next y value would go from 5 to 7. Okay? If it was any other y value, it would not be linear because the slope wouldn't be constant for all points. Okay, and then the last one, part B. Let's do the same kind of thing. We're going from 10 to 16. Looks like we're adding 6. Adding 6 again. Let's just make sure the y changes, the x change I mean is constant. It goes from 0 to 1, 1 to 2. So if the x goes up 1 more, I know the y is going to go up 6 more again. Okay, 22 plus the 6 should get us a value of 28.